This is our lesson on simplifying rational expressions. A rational expression looks like the following. This is one example. X plus 3 times x minus 2 times x plus 4, all divided by x minus 4 times x minus 2 times x plus 3. And what you're looking for here are things that are the same on the top and on the bottom. Things that, if you divided them by each other, you would get 1 for an answer. There's one thing that you have to be careful of here. Things that are connected by an addition or a subtraction sign cannot be separated. So for example, this x has to stay with the 3. This x has to stay with the negative 4. So we can't get rid of these x's because they're the same and leave the 3 and the negative 4. Okay. The x has to stay with the 3, the x on the bottom has to stay with the negative 4. So when we look at this, we have x plus 3 on top. We need to look for an x plus 3 on the bottom. And we do have one. X plus 3 divided by x plus 3 is 1. X minus 2 on top, x minus 2 on the bottom. X minus 2 divided by x minus 2 is 1. The reason we can cross them out if they're 1 is because if we've got 1 times 1, that's 1. And if we multiply 1 times whatever's left, we're just going to get whatever's left. Okay? When you multiply by 1, it doesn't change your answer at all. So that leaves us with x plus 4 over x minus 4. Notice these look very similar, but we cannot simplify this anymore because the x plus 4 is different than the x minus 4. Here's another example, this one a little bit more difficult. We start out with x squared minus 2x minus 8, and we divide it by x squared minus 3x minus 15. The last one was already in factored form. This one is not, so the first thing we need to do is factor it. I've put the factored problems right there for you. Not going to go through those, but you can see the work. The top factors into x minus 4 and x plus 2. The bottom factors into x minus 5 and x plus 2. We have an x minus 4 on the top, but we don't have one on the bottom, so that's going to have to stay there. We have an x plus 2 on the top and an x plus 2 on the bottom. We can cross those out, and that leaves us with x minus 4 over x minus 5. One last example. We have 4x squared plus 12x plus 8 over 2x squared plus 4x. Again, the first thing we need to do is factor. On the top, all of these are divisible by 4. So we take a 4 out of each one. 4x squared divided by 4 is x squared. 12x divided by 4 is 3x. 8 divided by 4 is 2. Okay, so we take the 4 out of each one, and we're left with x squared plus 3x plus 2. Then we need to factor the x squared plus 3x plus 2. And that factors into x plus 1 and x plus 2. So on the top, we have 4 times x plus 1 times x plus 2. On the bottom, we can see that both of these are divisible by 2, and they both have x. So we're going to take a 2x out. If we take a 2x out of 2x squared, we're left with x. And if we take a 2x out of 4x, we're left with 2. So on the bottom, we have 2x times x plus 2. Now we can see that on the top and on the bottom, we have an x plus 2, so we can get rid of those. We have an x plus 1 on top, we don't have an x plus 1 on the bottom, so that's going to have to stay there. We have a 4 on top and a 2x on the bottom. Remember I said that things cannot be separated if they're connected with a plus or a minus sign. Well, the 2 and the x aren't connected with a plus or a minus sign, they're connected through multiplication, so they can be separated. So we can separate the 2 and take 4 divided by 2. 4 divided by 2 gives us 2. The x is still there on the bottom. So on top, what we have left is 2 times x plus 1. On the bottom, we have x. And if we take a look at that, even though we have this x on top and this x on the bottom, we can't simplify that any further, because remember, this x is connected to the 1 by the addition sign. We would also have to have an x plus 1 on the bottom.